So, welcome to our tutorial 1 for week 1. In this tutorial, I shall solve some basic questions or numericals so that you can understand that based on the theory, how do you apply while solving in numbers. So, very first topic is the using the transformation law. I think in your undergraduate levels, two-dimensional transformation is taught, like if we have, this is my x-axis, this is my y-axis. If another coordinate system which is making an angle theta with the x-axis, let us say x dash, and this is y dash. So, it will make an angle theta. So, if somebody is interested to find out the force or a displacement, let us say we know that the components of, first of all we will write a transformation matrix. So, x dash will have two components, one is along x axis, one is along y axis. What will be that? That along x axis it will be x dash cos theta. I am going to write like this, x dash cos theta. Then along y axis it will be x dash sin theta. This y dash will have two components along this and along here. So, it will be minus of y dash sin theta along x axis and y dash cos theta along y axis. Now, you arrange the components. Let us say x will be x dash of cos theta along x axis, x dash of cos theta and minus y dash of sin theta. Then along y axis the component x dash sin theta and plus y dash cos theta. Now, can we arrange in terms of a matrix? Let us see x, y, cos theta minus sin theta, cos theta, x dash and y dash. This you will say that this is the mathematics, that how do you transform, or our aim is to find out in terms of x dash and y dash. Let us say this is your matrix Q, or in general terms we will say that this is our matrix T, transformation matrix. But in generally theory of elasticity or engineering mechanics, we define by a Qij transformation matrix. So, here we will say that let us say Qij, which is a 2 by 2 matrix. At some point of time, you may know that value along x and y, and you are interested to find out the values along rotated axis. In that case, x dash and y dash will be inverse of this and xy. This transformation is valid when you are having a vectorial quantity, means a vectorial quantity means first order tensor vector. So, this if you write that x and y, interest of you say that u v w fx fy, so you can add and transform accordingly. Where we are going to use this mathematics. Let us say a composite. We know that in a composite one is fiber, along that material property is highest. So, let us say a lamina, this is our a rectangular lamina in which graphite fiber or glass fibers are oriented like this. Okay. So, we know only property of fibers that this is your direction, sorry, this is your direction. You take a lamina in which direction of fibers is like this at an angle, let us say theta degree with the x axis. So, we know that material property of a fiber along this direction. So, our fiber is in this direction. So, perpendicular to this 90 degree 1 and 2. So, if we know that E1, E2 and other properties, stresses, but we are interested to find out properties along x axis and properties along y axis. Then we have to use the concept of transformation. But vector, for I said that if it is x and y, then cos theta minus sin theta. Let us say I am going to write sin theta, cos theta and so on, x dash and y dash. But if you are talking about a second order tensor, like stress or a strain, sigma, sometimes we call it as a matrix entities, matrix components, entities. So, how do you transform this thing? So, for a vector, let us say any vector u can be transformed. Q, you say I here, ij and uj, और u dash बोल सकते हैं. For the case of a second order tensor, then it will be, or in terms of a matrix, Q sigma dash and Q transpose, like that. This I am going to explain you. Now talk about transformation in 3D case, 3-dimensional, where you have x1, x2 and x3. Then you have rotated this frame, let us say, or slightly like this, let us say x1 dash, x2 dash and x3 dash. This is your general transformation, that in 3-dimensional how do you define a coordinate. But generally for the case of our composite, we say that that x3 is coinciding with that rotating only x and y, not z is not, or around the z the rotation is there, because if you are talking about a composite material in which this fiber angles rotate about the z axis, so x and y. So, our equation will becomes x1 dash, x2 dash and x3 dash is same. So, mostly for composites we use this kind of information, that around the z axis is coinciding and in plane axis the x1 is making an angle theta with x axis or y axis, whatever you want to say. But in general sense it may also have a completely rotation of a about the z also. So, how do you evaluate a transformation matrix Qij? That the standard rule. So, if I talk about a single element, it will be cosine of xi dash dot xj. So, if we are interested to find out a Qij matrix, then x dash is making with x1 will be a cos component. So, according to, if you say I is equal to 1, j is equal to 1, then Q11 will be nothing but cos of x1 dash to xj dash, again 1 dash, making in with angle, here is comma. Now, Q12 x1 dash will make x2 cos x1 dash will make x2, that angle. Similarly, we can calculate all the elements. If we say that I is taking 1, 2, 3, j is taking 1, 2, 3. So, you can evaluate all the elements by following this law. Now, I am going to implement a numerical. Let us say your x1, your x2, x3 and another x1 dash is making an angle of 60 degree with the x axis, and this is x2 dash and x3 dash is same with the x33. Now, you have to evaluate Q matrix. First of all, we will write all the elements Q11, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. So, the first element x1 dash is making with x1, what will be that? Cos of 60 degree. Then x1 dash is making with x2 dash, which will be cos of 30 degree. Then x1 dash is making with x3, it will be 90 degree. Then 2, x2 dash is making with x1, which is coming 150 degree. Then x2 dash is making with x2 cos 60 degree and cos 90 degree. Then x3 dash is making with x1 90 cos 90, x3 dash is making with x2 cos 90 and x3 is making with x3 cos 0. This is your 3-dimensional transformation matrix when x3 dash is equal to x3. So, now you just put the value, it is becoming 0 at this one. So, basically you have to evaluate. If I tell you that evaluate any f or evaluate any u, you have to just multiply this matrix With that, let us say we are interested to find out any vector A whose values are given, let us say 1, 4 and 2, and now we are interested to find out A dash. So, A dash will be nothing but Qij and A1. So, if you multiply this matrix with this A1, you will get A1 dash. If you know the components along x-axis x1, x2 and x3, and then you can rotate along the rotated component. The vice versa, you take inverse of this. Now, let's talk about a matrix component Aij. Let us say 1, 0, 3, 2, 4, 2, 1, 6, 9. We have this. Now, we are interested to find out Aij dash. What will be that? It will be Qip, Qjq and A of basically Ij. This is an index form, but if you are interested to know in matrix form, then it will be Aij, or I will say that A dash will be equal to Q A and Q of transpose, like that. So, you put Q matrix, then A matrix, then transpose of this matrix, multiplied together, you will get A matrix along the transform coordinates. Now, we can implement two transformation of strains and stresses. So, here you see, generally in lamina case we ask about 2D, or and that around 3D it is a constant. So, in same way you say my 1 or 2 and 3 and then some rotation, 1 dash, 2 dash and 3 dash is same, making an angle theta. So, basically epsilon I j dash can be written as Qip Qjq epsilon pq, or in matrix form epsilon dash can be written as Q epsilon Qt. So, Q for this case, already if I are talking about even for 2D, I have explained 1 and 2, 1 dash and 2 dash. So, if you are talking about 3D, so third element about that axis will become 1. So, we can say that cos theta, sin theta 0, then minus sin theta, cos theta 0, 0, 0 and 1. You say that cos 90, and if you take the transformation, this becomes like this. So, if you put it here, so cos square, sin square and some sin cos terms will be there. So, if I write epsilon x dash will be epsilon xx cos square theta plus epsilon yy sin square theta, then plus 2 of epsilon xy sin theta and cos theta. If somebody is interested to find out epsilon xx dash, one can find out like this. Similarly, epsilon yy. So, basically you substitute those value epsilon. What is your epsilon? Epsilon is like epsilon xx, epsilon xy, epsilon xz, epsilon yx, epsilon yy, epsilon yz, epsilon zx, epsilon zy and epsilon zz. This is your matrix. So, if you multiply with this, you can get all the components. What will be my epsilon 1 1, what will be my epsilon xy. Now, for stresses, generally in theory of elasticity, we used to ask that, let us say this angle is this one. So, we know that stresses along x axis sigma xx, sigma yy. So, what will be, or I would like to say that not 1 axis, 2 axis, 1 dash and 2 dash. So, our aim is to find out sigma xx dash, sigma yy dash. So, here also again you have same way, like sigma you can put it. If you talk about a 2 dimensional, then it will be sigma xx, sigma xy 0, then again sigma xy. Your matrix will look like this when you are talking about purely a 2 dimensional matrix. Then cos theta, sin theta 0, sin theta, cos theta minus 0, 0 0 1. So, ultimately this is your matrix basically. You even not required all these things. Then you can, they are going to be 0 quota affecting that, or if you can put that exact. But for our present case, we have chosen that along z axis it is not rotating. If it is rotating with the z axis, so this component will also come non-zero components. So, this is a important point, that whenever we say that around z axis rotating, these components are going to be 0. But in some special questions, or there are some problems like in robotic hands or some others, where even around z axis it is also rotating, then this cannot be 0. But for our present structural mechanics theory of plates point of view, we generally take 0 0 and 1 like this. So, it will be cos square theta plus sigma yy of sin square theta plus 2 tau xy sin theta and cos theta. Then sigma yy will be sigma xx of sin square theta plus sigma yy of cos square theta minus 2xy sin theta and cos theta. Now, you have understood that how to transform a second order tensor, but you have a fourth order tensor also, Cijkl, which is a fourth order tensor. Then Sijkl, and what about how to transform these things? Then again, if I talk about Qij, again I am saying Q, reduce stiffness, Q bar बोल सकते हैं, reduce stiffness matrix, standard notation. Don't confuse with that transformation. That's why I would like to say that the transformation you can denote by T, and for in Platon shell we say that reduced stiffness matrix, the components are Q11, Q12 and so on. Don't confuse with that transformation. So, all these are fourth order. So, now you see that when you are talking about a first order tensor with a vector, you have either sin theta or cos theta. But when you have a second order tensor, then you have a sin square theta cos square theta and combination of this thing. When you will have a fourth order tensor, it means you will have a 4 times of this and different combination of this sin square theta, cos square theta and so on. If I say that is a third order, so it will maybe sin cube, cos cube and so on. One can understand that how to start a transformation of this. So, these are the standard rules are given. You go through any theory of Plato book. In the very first chapter, the basic, even I have shown you in my presentation also, that how Sijk can be represented or Q1, Q12 can be represented in a transformed coordinate system. These are very much required if we talk about a composite. If you are talking about only a isotropic plate, then this transformation no meaning. But when you have a composite plate in which fiber is make any angle with the geometrical axis, for that case transformations play a major role.